There, this is Dr. Satish, Assistant Professor at British Applied College. I welcome you all to this video lecture. This is for ENG208 Mechanical Principle Unit for Level 4 Pearson Higher National Diploma students, okay, Mechanical Engineering students. Now, in today's video, we will look into how to calculate reaction forces for a cantilever beam. So far in my previous video lectures, I said about how to calculate reaction forces for simply supported beams in three different loading conditions: point load, uniformly distributed load and uniformly varying load. Now we will look into a cantilever beam. So in front of us we have a cantilever beam, okay. So the cantilever beam, I can say this by one end being fixed and the other end is free, okay. Now the load is applied. I can see two types of load in this problem. One is a point load 3 kilonewton and the other one is 2 kilonewton per meter. Please watch out for the units. So I mentioned here by kilonewton, I mentioned here by kilonewton per meter, okay. So look for it. And so the total load acting on the beam because of this uniformly distributed load is so 2 into the distance, okay, distance along which it acts. So 2 into 2, so the totally 4 kilonewton this will be acting, okay. Now for a cantilever beam of such setup, first we have to draw the free body diagram, okay. For a simply supported beam, there will be only vertical reaction forces, okay, but for a, you can see here, okay, there will be only vertical reactions. But when it comes to fixed support, okay, when it comes to fixed support, we will be having both vertical reactions as well as moments. That is very important, okay. So let me draw the free body diagram for this. If I draw the free body diagram, it will be like this. I'll be drawing the beam and reactions, okay. I will be having a vertical reaction RA, okay, and moment, okay. So at this point A, please understand, at this point A there will be two reactions, okay, I mean two modes, okay. One is reaction force, the other is reaction moment, okay. So please understand that. Now we have to find these reactions, okay. That is what our aim of the problem. Now I will be applying the load, okay. So I can just copy this here, copy, yes, so I can just apply it here, okay. Now for such a, 1 minute, yeah, now to find RA and MA, as we used equilibrium equations in our previous problem, we will be using them now, but I will just copy it here. See, there is two unknowns, okay, you can see this, there are two unknowns, so we have to use two equations, okay. As usual, there are no horizontal forces, so I will be not considering this, and I will be using only two equations, okay. So if I write my first equation, summation of forces along the y direction is equal to 0, okay, I will be considering positive upward forces as positive, okay. You can consider the other way around, that is completely fine. Now there are only two, see, there are only two vertical forces. So if I write that, then I have upward force positive, so RA is supposed to be positive and this is negative, okay. So minus 3 kilonewton is equal to 0. So finding cases here, it's very easy for me. So RA is equal to 3 kilonewton. I am done with finding one reaction force. Now I have to find only the moment, okay. Now I apply the second equilibrium equation, summation of m at any point equal to 0. I consider point A and I am considering anti-clockwise, okay. I am considering anti-clockwise as positive. In this case if I write my moments, okay, you have to understand, so far when we are considering moment at point A in simply supported beams, there is no reaction moments, and because of RA, okay, because of RA you have to understand there is no, because of RA there is no movement happening at A, okay. But in cantilever beam we have a reaction moment, please understand that, okay. We have to definitely include this in the moment equation, okay, and it is in the anti-clockwise direction, so I will take this as positive, MA positive, okay. Now we have to look for other forces, okay. As I said, in the simply supported beam RA will not cause any movement, so I will not consider that. I will not consider that. Now I have two other forces apart from RA, okay. So 3 kilonewton acting at a distance 3 meter, okay. First let me introduce that. So if I apply 3 kilonewton, my body will rotate in the clockwise, so I will take this as negative. Yes, correct, negative. So 3 into, what is the distance? 3, okay, 3 into 3. Now the other force which is acting is uniformly distributed load. So the total load is 4 kilonewton, the intensity of the load, the equivalent point load, if I consider, it will be acting exactly at the half, okay. So it is running over 2 meter length, so exactly at the half in the sense 1 meter, okay, 1 meter either side. So the distance of this exact half part is from A is 3 plus 1, here 3 plus 1, so it will be 4, okay. So minus, again the direction, you see, if the intensity of the force, the total force which is exactly acting in the middle, okay, middle of the total 2 meter length, because of this force it rotates in the clockwise direction, please understand that. Now minus 4, okay, because the total load is 4 into distance is 4, okay. Wow, it's 3 into 3 into 4 into 4, okay, a rare coincidence, that is equal to 0. So now MA is equal to 9 plus 16, so that is equal to 25 kilonewton meter. Be aware of what the units you write, okay. So this is how we solve the problem. Reaction force, calculating reaction force and reaction moment in a cantilever beam. Thank you guys, let me see you all in the next video.